numbers as powers of 10. Learning goal. I can use powers of 10 to describe any number. What do the following numbers have in common besides being powers of 10? So 10 to the third, 10 to the fifth, 10 to the seventh, and 10 to the eighth. Well, they're all numbers that start with a 1 and are followed by some zeros. They all have the same number of zeros as their exponent following the 1. So 10 to the third is a 1 followed by 3 zeros. 10 to the fifth is a 1 followed by 5 zeros. And so on, 7 zeros and 8 zeros. Perhaps more importantly, they're all place values. So 10 to the third is the thousands column, 10 to the fifth is the hundred thousands, 10 to the seventh is the 10 millions, and 10 to the eighth is the 100 millions. The expanded form of the number 5,425 is 5 thousands plus 4 hundreds plus 2 tens plus 5 ones. This can be written mathematically as 5 times 1,000 plus 4 times 100 plus 2 times 10 plus 5 times 1. Or putting in brackets, which can sort of help separate each of the terms. The brackets aren't necessary because order of operations tells us to do the multiplication first before doing the addition, but the brackets can help you in understanding the problem. So using our knowledge of powers, though, we can now rewrite that as 5 times 10 to the third plus 4 times 10 squared, or 10 to the second, plus 2 times 10 to the first, plus 5 times 10 to the 0. Typically, we don't write in the 1 exponent, we just do times 10, and we don't usually bother putting in the 5 times 10 to the 0 because that's just 1. Let's try writing out the number 75,302 in expanded form as powers of 10. So we start off with 7 times 10, and we want to know what exponent to put on the 10. Well, we can see that there's 1, 2, 3, 4 place values following the 7, so we're going to do 7 times 10 to the fourth, plus 5 times 10, and since there are only 3 place values after the 5, we're going to put times 10 to the third, plus 3 times 10 to the second, plus 0, so we can just ignore the 0, and then plus 2. So 7 times 4 is 70,000, 5 times 10 to the third is 5,000, 3 times 10 squared is 300, and then we just have a 2. And you can see that if we added all those together, we'd end up with 75,302. Now we're asked to go the other direction to write the following equation in standard form. So if we're going to write it in an expanded form, we might do it as 4 with 5 zeros after it, plus 3 with 3 zeros after it, plus 7 with 2 zeros, plus 6 with 1 zero, plus 1. However, we're asked to go straight into the standard form, which is just the regular form that we're accustomed to for numbers. In some cases, it's easier to actually start on the right-hand side. So we're going to start with the ones column, and we'll just write a 1. Then we've got 6 times 10, which is 60, so we know that that goes there. 7 times 10, that's hundreds, so we'll put a 7 in that place. 3 times 10 to the third is thousands, so we know that that goes right beside. However, we don't have a 10 to the fourth, so that means we're going to put in a 0 placeholder, and then the 4 10 to the fifth. So just to recap, we're going to have 5 spaces after the 4, and we've got 1, 2, 3, 4, 5 spaces. 3 times 10 to the third, there should be 3 spaces after the 3, and there are 3 spaces after the 3. So I feel fairly confident in saying that that is the number that is the standard form of this equation. Now it's your turn.